Hello everyone, welcome to my YouTube channel Learn AI Together. In this video, we discuss the topic of measure of relation. What do you mean by measure of relation means? Till now, we are we are discuss the topic of descriptive stats. In descriptive stat, we are know the topic of univariate analysis. Everybody know about the what do you mean by univariate analysis. So in univariate analysis, we are dealing the procedure with only one column. With only one column means if there is a person, only one person, we are dealing with this person attributes. Similarly, for in descriptive stats, we are going for a bivariate analysis. Bivariate analysis. Let me let's try to something called as bivariate analysis. So here in bivariate analysis, we are dealing with two columns instead of one column because here uni means one, here y means two. So we are dealing with two columns. Now, now let's here there are two persons. Now we need to find a relationship. In between them. How much strong? So now we want to find how strong they have in relationship. They have in relationship. So so the learn some way of relations, some way of relationship. We are using the concept of measure of relation. So so in measure of relation, we are using the two measures for calculating the computing the relationship. Those measures are nothing but one is the covariance and one more is correlation. Now, now, but first we go for covariance. In covariance, so for better understanding, we take an example. What do you mean by covariance? Now, what do you mean by covariance means? For better understanding covariance, we take an example. In this example, we have a data set like data set. This data set contains three columns. The first column is nothing but height. This is a numerical column, and weight. This is a numerical column, and this is a gender column. It is a categorical column. Suppose we are dealing with two variables only. So now I take height and weight column for this data. Suppose here there is a person. This person having the height like 180 centimeters and weight is 80 kgs. Now visual way to represent. Now I want to represent in visual way. In visual way. Visual and graphical way. So for this I need a graph. In graph, x-axis, y-axis. So x-axis having the heights column and y-axis having the weight values. So here the height values are present. Here the weight values are present. So here this person having 180 centimeters. Now think this is a 180 centimeter and this is a 80 kgs weight. Now third person lies here. Okay. Now this data having only doesn't contain only one point. This data having various type of data points. Okay. For this thing, I want to plot some plot. This plot looks like this, and this x-axis having heights and this x-axis y-axis having weights. I want to plot some data points from data sets. So the plots look like this thing. Let's suppose the okay. The plots look like this thing. This plot is also known as scatter plot. Okay. Here, when we observe this scatter plot, we observe in this scatter plot the weight column is changed when the height column is changed. Means if the height column is increased, the weight column is automatically increased. Means the height is directly proportional to the weight. Okay, this is nothing but directly proportional. It is denoted by directly proportional. Okay, when the height is directly proportional to the weight, this plot shows. Now in another scenario, if height increases, then weight decrease. Means here we can say that the height is inversely proportional to the weight. Inversely proportional. So for this thing, the plots look like in decreasing manner. Means one column is increased and another column is at a time decrease. Okay, here weight column and height column. Now in another scenario, the plots look like something. Sometimes the plots look like this thing. So here we can say that there is a no relationship in the data points. No relationship. Okay. now the question is there any math way to compute these relationships? These relationship for this question, the answer is yes, and that measure is known as covariance. Okay, so that measure is known as covariance. So here in covariance, I want to show some interesting point. So some interesting thing. Okay, those interesting is nothing but, look here. Variance is looks like summation I equals to 1 by n xi minus mu. Also, when we are dealing with variance, there is only one variant. When we are dealing with covariance concept, variance is here, variance is known, but co is nothing but 2. So we require two variables. Those variables are nothing but some, like, let's think x comma x. Now I want to expand this square term. Okay, summation xi minus mu x for one column and xi minus mu x for second one. This is for this thing, this is for this thing. Don't confuse. Now here we talk about two variables instead of one variable. Instead of one variable. Okay. So now I want to replace this thing with y. Same here, x comma y. Summation I equals to 1 to n divided by n. The xi minus mu x for x thing, yi minus mu y for y. Here the formula contains two variables. This is nothing but covariance formula. Okay. By using this formula only, we compute the covariance. Okay. It is nothing but, it is a covariance formula. Now these covariance, here we observe the in covariance formula there is a no square term. There is no square term. In variance we have a square term. That is the reason every value should be converted into positive. In covariance there is a no square term. We observe here there is a no square term. So it gives either positive negative. It is also gives either positive negative thing. So when we covariance gives x comma y gives something positive value, it means if one column is increased, automatically another column is also increased. If covariance of x comma y gives negative thing, it means if x is increased, another is decreased. That is y is decreased. Let's data set. Now let's I have data set like height and weight. Okay. Now after computing covariance of x comma y by using the formula, it will be looks like something 9, 4, 6, something 5, 9. So covariance here, covariance consider only signs. Consider only signs. Magnitudes only consider. It won't consider these values. For this, it has no means. Okay, no meaning. For this, it has no meaning. Now, it is a drawback for covariance thing. So, and covariance have another drawback is nothing but it won't capture the how much relationship is in between data points. Okay, it won't covariance won't tell us how relationship occur. Okay, means if the relationship occur like strong relationship or loose relationship. Covariance won't tell us. It means, I will take an example for better understanding. I have a data set like this. These data sets contain a comma b columns, and I have another data set like a comma b columns. Now I want to plot a scatter plot for this data, and these data points look like something this. Okay, for this data I want to draw a scatter plot, and this data looks like something this thing. Here in this plot we can observe, here in first plot we can observe among the data points, the distance between the data points, the distance is more compared to this plot. Here the spread or distance is more. So we can say that it has loose relationship. This diagram, in this plot, the distance is less. And the relationship is strong. Okay? These loose or strong relationship held by the covariance. Okay, it only consider sign values, it won't tell the how much strength in the relationships. Okay, for this thing, for this drawback, we cover the topic of correlation. These drawbacks solved in the correlation topic. Okay, now what do you mean by correlation? Correlation is also known as Spearman relation. Spearman correlation coefficient. Correlation coefficient. It is denoted by rho of, here we are dealing with two variables, rho of s comma y, and formula looks like covariance of s comma y divided by sigma of x into sigma of y. Here covariance of xy is nothing but summation I equals to 1 to n xi minus mu x and yi minus mu y. So sigma x for this data, s column data, sigma y for y column data, standard deviation. When we divide the covariance with standard deviation of x and standard deviation of y and multiplied, then the correlation gives the values in between -1 to +1. Means the correlation is always lies in the range of -1 to +1. Okay, this is the reason why correlation is lies between the -1 to +1. Here in correlation, we tell the how much strength in between data point, how much strength is present in between the data points. Okay, covariance won't tell us this thing, so it also tell us to direction of the data points. Means either it have a positive direction, either it has a negative directions. Okay, in correlation we solve the drawbacks of covariance. Now correlation plots looks like this thing. Okay, and this thing also known as heat map. Everybody know about heat map. This heat map contains the cell values, and these cell values represents the values like 0.95, 0.7, minus 0.2, like these values are contained, because correlation is always lies in the range of -1 to +1. So suppose this value having the 0.95, this value contains 0.2, this value contains -0.9, this value contains 0.2. In this case, here the bar also will be present in correlation bar. This bar will indicate the dark colors having have strong relationship, and weak color means means light colors show weak relationship. Okay, weak relationship. Here to here we consider as positive, here to here we consider as negative. Means if suppose this data contains +0.95, means here will be a positive correlation, and the strength is nothing but 95% in between the data having the relationship. When we talk about -0.9, here we have a negative correlation and the relationship is 90%. Okay, when we talk about +0. This is nothing but it has a positive relation and it has weak relationship. Okay, it has strong relationship. Beyond 7 we consider as the strong relationship. Greater than 7, less than 7 we consider as the weak relationship or loose relationship. So it is nothing but correlation. Now these correlation have the drawback. Those drawback is nothing but drawback in correlation. Those drawback is known as a rate of change. This rate of change we cover the topic of regression when we are dealing in ML class. These topic covered in ML classes, machine learning classes. Okay. For now, the rate of change is nothing but I want to give some example to understand the concept of rate of change. Okay. Suppose a person is there, he has the institution or some business. Now he want to improve the but he had an institution, let's think. Now he want to increase institution admissions. Okay, now he wants to do marketing or increase the admissions. These marketing platforms having various platforms. That is nothing but one is a newspaper platform, one is a digital platform, one is a something like metro platforms. So now I have a graph for a newspaper platform, I have a graph for digital platform, I have a graph for metro platforms. When we using the data, when we plot a diagram for newspaper platform, it seems like this thing. Okay, when we have a data, then I plot for digital platform, the data looks like this thing. For this thing, data looks like this thing. Among them, which one is the better graph? Means this x-axis in every plot having the investment. Okay, this y-axis in all the plots having the profits. Now among them, which one is the better? Both among three have the positive relationship and strong relationship. Now we can't say which one is the better by using the correlation. Now we understand the concept of rate of change. Rate of change is nothing but how much is affected by changing one unit. Okay, suppose here to here 1 unit, here to here 1 unit, here to here 1 unit, here to here, here to here 1 unit, here to here 1 unit. When we think like 1 to 10, 20, I want to invest 1 rupee. Here I get the profit like 10 rupees. Here I like the profit like I invest 2 rupees, I got the profit of 20 rupees. When I invest 1 rupee here, the profit looks like something 10. When I invest invest 2 rupees, the profits look like something 15 rupees. When I invest 1 rupee here, the profit looks like something 10 rupees. And here, when I invest 2 rupees, the profits look like 12 rupees. Among them, we have a same investment. Among in three plots, we have a same investment. But profit is in the newspaper platforms. Okay, wait a second. So, so among them, newspaper platform is the best thing. Then we can easily suggest that person don't invest in digital platforms. Don't invest in digital platforms and metro platforms. Means invest, but less invest in digital platforms and metro. More invest in newspaper platforms because you have the profit in newspaper platform. You get more profit in newspaper platform. This is the reason why rate of change is more important in our data science domain. Okay. So in depth we go for the rate of change in machine learning when we are dealing with regression topics. So now I want to show something for you for better understanding of correlation plots. Okay, those are nothing but I want to show some plot for you better understanding. For better understanding, wait, give me 1 minute. So correlation has one more drawback. For seeing this data, we can easily say that it has a drawback. So the diagram looks like this thing. Wait a second. Now the diagram looks like this thing. Okay. When we observe here, these data points having the same relationship. Okay. The difference is there is a positive relation, here also positive relation, here also positive. But here we have the strong relationship in between the data. Here has some less strong. It has less weak relationship. Okay. Here we can say that there is a no relationship. There is a no relationships. Okay. This is nothing but how rate of change is affected. This is an example for rate of change. Okay. For among these, we can say that this is the best thing. Okay. And this is nothing but it has no pattern. Okay. It has neither present in positive direction, neither present in negative direction. So it is known as non-linear patterns. Linear patterns. These from this we can say that correlation capture captured non-linear patterns also. Non-linear patterns. Now till now we covered the topic of descriptive stats. In descriptive stats, we are cover the topic of univariate analysis as well as bivariate analysis. In univariate analysis, we cover the topics of measure of central tendency, measure of dispersions. In bivariate analysis, we cover the topic of measure of relations. In this, we cover the topics of mean, median, mode. In depth. Okay. Here we cover the topic of range, IQR, and variance, and standard deviation, and median absolute deviation. So in this, we have a robust. Which one is robust? Which one that is present in our previous videos. In measure of relation, we cover the topic of covariance and correlation. But it is nothing but descriptive stats. In next videos, we go for some probability based concept. Here we can learn the concept of what you mean by probability and what you mean by random variable, what you mean by event, what you mean by sample space, what you mean by PMF generating functions, and as well as PDF, as well as CDF generating function. After covering these topics, we go for distributions, and after covering the distribution, we go for the main concept like why we required a Bayes theorem. So after doing some Bayes theorem, before we dealing with Bayes theorem, we go for marginal probabilities and joint probabilities and conditional probabilities. After this thing, we cover the Bayes theorem. After Bayes theorem, we go for something interesting like central limit theorem. Okay, this dot is connected. How this dot is connected, I will show everything in our next videos. If you gain some knowledge from my side, please guys like and subscribe my videos. That is needed for me to share more knowledge for you. Please like and subscribe. Hope you understand. If you didn't understand anything, please comment in your comment box. Okay, thank you guys for watching. Have a nice day. Bye bye.